Hi folks, welcome to another Algebra 2 Skills Review video lesson. This is for standard A-REI.6, and this one states to solve systems of linear equations exactly and approximately. Approximately is going to be with graphs. Exactly is going to be solving by either, you might remember elimination, also called linear combinations, and there's also substitution. And we're going to focus on pairs of linear equations in just two variables for this exercise. Okay, so we're actually just going to look at one linear system, and I'm going to solve this graphically and then exactly. As it turns out, the graphical solution is also going to be exact, but that's just a nice coincidence there. Okay, so I need to solve this linear system here, right? 4x plus 3y equals 12, and 2x minus y minus 6 equals 0. And I'm going to graph this. So my first equation, this one here, I'm not overly comfortable. Well, I can do it certainly, but it's certainly in a form where I can graph this as is. I can make what we call a quick graph. If you notice here, the coefficients of 4 and 3 both go into 12 evenly. When that works out like that, we can actually just graph our x and y intercepts. So what I'm going to do is I'm going to cover that for a second. Erase that. And I'm just going to rewrite this, 4x plus 3y equals 12. And what I'm doing here is I'm going to let x equal 0. Right? That will give me my y-intercept, whenever x is 0. Well, what happens when we do that? Well, when x is 0, this term is going to go away. Okay, sorry about that. This first term is going to go away, and I'm going to get 3y equals 12, right? 3y equals 12, or y equals 4. So that gives me the point 0, 4. Okay, well that means I'm going to go up on my y-axis 4 units, x coordinate is 0. Okay, I'm going to do the same thing, and this time I'm going to let y equal 0. So I'm going to put my little hand over the 3y, because y is now 0, and I get 4x equals 12. All right, let's continue this down. Let's y equals 0, and I get 4x equals 12, 4x equals 3, right? A little division there. Okay, so that gives me the point 3, 0. All right, I go back to my graph. There's 3, 0. And now you certainly should use a straight edge. I really don't have that option on my smartboard, believe it or not. I'm just going to try to line this up as best I can. I think I did an okay job there. All right, so there's my first line that I've graphed. Again, I did a little quick graph. For my second one, my 2x minus y minus 6 equals 0, you might be a little more comfortable with getting that into slope-intercept form. I'm going to get y by itself, which I'm just going to get y over to the right side. And I get 2x minus 6 equals y, or I can write it in the nicer way, which is put the y first. Y equals 2x minus 6. So I can graph my y-intercept is right here at negative 6. There's my y-intercept. So I'm gonna put 0, negative 6 on the graph, and then my slope is 2, right? Whoops. So S-L-O-P, E, slope equals 2. So I'm going to go up 2, right 1, there's my next point. Up 2 again, right 1, there's another point, and so on, until I get a bunch of points, and there's my line. Again, approximately, and maybe something more like that. Okay, so the question is, where do these two lines intersect? That's going to be the solution of this linear system. Well, it's certainly intersecting right there. That looks like the point 3, 0. So if I'm doing this approximately, it's just by visual inspection. Where do they intersect? Well, they're intersecting at 3, 0. I can certainly check this. Again, if I get like a decimal answer, if these were intersecting, somewhere like up here that wasn't at full numbers, this might not be as easy to see. I would just make a guess here. But 3, 0, I can certainly put back in my equations and see if it works. And remember, it has to work in both sets of equations, right? So if I do my first equation is 4 times 3 plus 3 times 0 equals 12, and that's a big old question mark there. I get 4 times 3 is 12 equals 12. Well, that's true. So 3 zeros certainly works in my first equation. Let's see if it works in the second. So 2 times 3 minus 0 minus 6, does that equal 0? Well, I get 6 minus 0 minus 6. Yeah, I get 0 equals 0, right? So not only is that approximate because we used the graph, I actually checked it, and it actually works out. We actually have the solution of 3, 0 exactly, as it turns out. Okay, so that's how we do, and there's a few things that we do there with the graphing. I graphed 2 different lines in 2 different ways. But really, it's whatever is comfortable for you to be able to graph a line and to do it in a timely fashion. Okay, I'm going to solve the same exact system, and now I'm going to do this algebraically. So no graphs this time. I'm just going to do some manipulations and solve this. So you may remember, first of all, I mentioned them earlier in this lesson. There's 2 methods for doing this algebraically. There's elimination, which you remember, or maybe you don't. It's also called linear combination. But I think most teachers now call it elimination. And there's also substitution. You can choose whichever method that you like. I'm going to show you one method. I'm going to do substitution here. I like doing substitution in these problems where one of my coefficients is either 1 or negative 1. And that's going to happen right here with my y term in my second equation. That coefficient is negative 1. It makes it really easy to isolate one variable. So I'm going to isolate one variable. And in this case, it's going to be the y from the second equation. So I'm going to start off by doing that. So in fact, I already did it on the last page, right? Didn't I already do that? Oh, I erased it. Sorry. I got y by itself, right? I added y to both sides, and I got y equals 2x minus 6. Hopefully you still have that in your notes. So I isolated one variable, and what I'm going to do now is I'm going to substitute that expression. I'm going to put 2x minus 6 in for y in the other equation. So I'm going to substitute that expression into the other equation. Okay, so let's see. I'm rewriting this line right here, the 4x plus 3y equals 12. So I have 4x plus 3. Now in place of y, I'm putting this whole other expression, 2x minus 6. And then equals 12. You see how I just rewrote this first line up here? This line right here that I'm moving my arrow at. I just rewrote that line, and now I have just x's. So I'm going to make another little note here. I'm going to solve for the remaining variable. So now I need just some basic algebra techniques. I know I need to distribute here, and I get 4x plus 6x minus 18 equals 12. And I can combine some like terms. I can get 10x minus 18 equals 12. At some point, I need to add this 18. I should probably do it right about now, if you didn't do it already before you combine like terms. I get 10x equals 30. And a little division by 10 is going to give me x equals 3. Which is what we had before, right? When we graphed the system, right? We got x equals 3. So I know I'm on the right track here, because I already did the problem. And then it's a lot like before, where I want to substitute this x equals 3 into one of these equations way up at the top. So I'm going to now again substitute. So I'm going to substitute that solution into either original equation. And once I do that, I'll be done. So I know x equals 3, so I'm going to go all the way back up to the top. I'm going to erase all this stuff, get it all out of the way, or get most of it out of the way, I should say. Get rid of this, get rid of this. And I'm going to plug in 3. I'm going to plug 3 in. I'm going to substitute 3 into this second equation because it just has smaller coefficients. So again, it's x equals 3. So it's 2 times 3 minus y minus 6 equals 0. And again, we're down to some basic algebra here. And I can combine some like terms. I have 6 minus 6 is going to be 0. I get negative y equals 0. So I can multiply by negative 1 there. Right? And I get y equals 0. Again, let me get rid of some of this other stuff here. So what do we end up with? We had x equals 0, y equals 3, so this is going to be 0.30. And again, just like we had before when we solved this graph. So I showed you here the substitution method, and that's the one that I showed you guys because, again, we had that coefficient of y was, in this case, negative 1. Positive 1 works really well, too. But if you like elimination method and you're comfortable with it, go ahead and do it, and that should work out just fine. Okay, so let's wrap this up. Did we do the things that we said we were going to do? Did we solve some systems? Well, yeah, we solved it. I solved one system. I did this approximately using a graph, and then I did this again exactly using the substitution method. And again, we focus on just here's a linear equations with 2 variables. We didn't do anything with 3 variables. That's definitely an algebra 2 topic. So hopefully this was helpful, and take care and have a great day.